Hey class, so I know we've already taken a look at arithmetic series and sequences. I know we've briefly taken a look at the geometric sequences where you see a set of numbers, you're like, oh, you multiply a number every time. We're going to take a further look into the geometric sequences, and hopefully today we can make it into geometric series as well. Okay, so the series and sequences are the same as the arithmetic ones. If you see a series, it's just going to be adding up the numbers in the sequence. Sequence is just a set of numbers. Like when you see 2, 4, 6, 8, that's going to be your sequence. This formula right here, that's going to be your nth term in a sequence. So like if you're trying to figure out how many rows, number of seats are in that nth row, n would be your number for your row. And then A of n would be the number of seats. So I'll kind of reiterate right there. A and n would be the value of your seats in the nth row. A1 would be the value of seats in your first row. Oops. N would be the number of rows that you're looking at. R is your common ratio. So just kind of like how arithmetic was with the D, but instead of adding a number every time, it's the number you multiply every time. You multiply it by the last number to get the next number. Okay, so in order to solve a problem, oops, I went a little too far, guys. I was practicing it. Bear with me. Sorry. Close your eyes, guys. Close your eyes. Okay, so if we see this sequence, we need to find the common ratio, find the explicit formula, the 8th term, and the next 3 terms. So, and I guess to determine if it's geometric. If it is geometric, we'll find the common ratio and be able to find everything else. So we're going to take the number on the left and divide it by number on the right. So for this one, it'd be 15 divided by 3. That gives me 5. This one is 75 divided by 15. Gives me 5. 375 divided by 75 gives me 5. So every single time we multiply the next number by 5, so that's our common ratio. So number 1 that we're looking for, common ratio, is equal to 5. Okay, number 2 is our explicit formula. So we saw it up here. A of n equals A of 1 r n minus 1. So I'm going to go ahead and rewrite it, just the generic. A of n is equal to A of 1 r n minus 1. We don't know what our nth term is, but we know our first term is 3. This is our first term right here. So the very first term we have in our sequence. Okay, times, put a little time there, r, and we know our r is 5. We found that in the last one, n minus 1. Okay, so now number 3, if you look in the question right here, number 3 is right here, looking for the 8th term. So that means I'm going to replace my n with 8. So A of n is equal to 3 times 5, 8 minus 1. And hopefully you guys know 8 minus 1 is 7. So 3 times 5 to the power of 7. So put it in my handy dandy calculator. 5 to the power of 7 gives me 78,125. Multiply that by 3. That gives me 234,375. Okay, and then the next 3 terms. So we know our last term is 375. So in order to continue the pattern, we have to multiply the next numbers by, so it's dot, 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 375. Then we have a next term, next term, next term. So multiply that by 5. 1,875. And then multiply that by 5. 9,375. Multiply that by 5. 46,875. Oops, 46,875. Okay, and that would be all 4 things that it asked for. So let's say we had the same instructions. Determine if the sequence is geometric. If so, find the common ratio, explicit formula, 8th term, and next 3 terms. So let's take a look at a different set for a sequence. Let's say your sequence is -2, 10, negative 50, 250. So I could do 10 divided by negative 2 gives me negative 5. Negative 50 divided by 10 gives me negative 5. 250 divided by negative 50 also gives me negative 5. So my common ratio is equal to negative 5. Okay, so I'm going to use that same explicit formula. So A of n is equal to A1 R n minus 1. Okay, so my first term is the one right here, right? So my first term is negative 2. I'm going to keep that in parentheses just to keep everything kind of coordinated. My R is negative 5. And then my, we don't know what n is yet, so it's going to be n minus 1. And that's going to be your explicit formula. Number 3, it's going to be the same as number 3 above, where it's asking for the 8th term right here. So I'm just going to replace my n with a 8. So A of n is equal to negative 2 times negative 5, 8 minus 1. So A of n is equal to negative 2, negative 5 to the power of 7. So I'm going to put this in parentheses. So parentheses 5 negative power of 7. That gives me negative 78,125. And we're going to multiply that by negative 2. That gives me 156,250. Okay, and that would be our 8th term. Okay, and then now the 4th one is just continue the pattern. So for the next 3 terms, so dot, 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 250, something, something, something. Okay, so 250 times a negative 5 gives me negative 1250. Okay, multiply that by negative 5. That gives me 6,250. And we're going to multiply that by a negative 5. Gives me negative 31,250. Okay, and so that is covering our geometric, that covers our geometric sequence. And then so next up would be our geometric series.